Hey, so this is actually, I apologize for the mess in my office. I'm probably gonna get the whole like YouTube thing set up better soon, but I really wanted to actually talk about the internals of this little demo app I did called Baseweight Snap, especially now that, Pocket Pal's out doing MTMD and Gamma's out doing multimodal. I wanted to talk a little bit about the challenges I had here and things I saw while actually developing this with llama.cpp. Now, the first thing that I want to talk about is the whole build process. It takes about 2 minutes on my gaming rig to build this, and it's because the way I build it is a little bit weird. Normally, when you build an Android application with native code, you actually build shared object libraries and bring them in. And I even wrote a blog post like way back when about how to build TensorFlow Lite for Android so that you can use in C++ before it was a fully properly supported thing that Google did back when I was at my last job. Now, the thing with Llama is that in their example of how to build an Android app, they just sort of bring in they symbolically link the entire llama.cpp directory and bring it in. Now that works for the main llama package, but it doesn't work for your common tools, like your common libraries and libmtmd. Now I know that this whole entire code has been refactored and I haven't updated it yet. I don't know if I am going to update it, but that's how I brought this code in to actually get it to work. So, and when I tested it on the Pixel 9, all these tests are on the Pixel 9 because it's what I had to turn on Vulkan so that it didn't drive me nuts for the performance because the performance was through the floor. The big downside of Vulkan is it only works on phones with 16-bit to registers. So if your phone doesn't support 16-bit registers, it only supports 32-bit, then you're not going to have a good time. And that's in fact most phones. Like when I was looking for tablets, I mean, I found an old MediaTek one, but it was too slow. But it did run. It did actually load the model. Uh, but when I found the Samsung Galaxy Tab A9, that didn't actually support it, so I couldn't use that device. So your mileage may vary. I don't know if there's like a good table somewhere or a good registry of which devices support which features in Vulkan. You think this would be something useful for Android gaming, but I don't know where that resource exists. So I also experimented with OpenCL, but it just crashed miserably when I tried. And the main two classes I wrote here were MTMD Manager, like the MTMD Android, which is just the C++ library that I connect my Kotlin to actually do that sort of stuff. So the stuff in here that we have is just sort of basic GNI bindings. I think the main thing that's interesting is here. This was annoying. So by default, what you would see in most C++ examples is actually file loading. Now, with Android, I already have a file loaded on the view in Kotlin, so I actually want to bring that over and actually convert it to BGRA into RGB or RGBA into RGB. This was a little bit weird because I got it wrong the first time. And then store it directly. You want to store that byte array data directly in, and you want to avoid the copy. Because, let's be real, the Pixel 9 isn't a super powerful device. It's kind of mid-range, to be perfectly honest. So you have to squeeze sort of every last bit of performance out of it. So it's going to be a lot of standard move, a lot of making sure that you don't do unnecessary copies. I mean, I probably do unnecessary copies in here, to be honest. I try not to. But one thing that I do, which I don't like, but I do it basically for the hackiness of it all, is I actually had to write my own chunking function because I found that I had an 8-second delay when you actually run MTMD eval chunks, which you're required to do to evaluate the initial prompt before you can generate the next token in the sequence. So I actually had to go and actually add this call, which would basically go and it would update the image content where we process our chunks sequentially, right? So this is where we go through all our chunks that we have, whether they're image or they're text, and we encode, decode, and evaluate. Now this has to be done sequentially. You can't parallelize it. I did try and parallelize it, and I kind of got it to work. It was a little crash prone with OpenMP, but it didn't really work. It just, like, it was the same speed and it crashed more, so I got rid of that. And then once we're done this, I bumped the progress bar up to 70%. You can see it actually when I actually relaunched the app. Like if I run app, so this is just gonna run the app. Right now I got it actually downloading off of Hugging Face because I realized that there wasn't enough value in having the model park anymore, so we're gonna rethink that whole thing. I mean, honestly, the startup's on hold right now while I figure my life out a bit. But so here we are, and we're gonna go. Okay, so we're here. We're in the app. What I use is a picture of my pack raft here. So I have a in camera. I have this, and I load this up, and then I tap this brain button. This is the describe button. This app was based on Hugging Snap, which was actually done with MLX on iOS. So I decided to try and make it, I don't know, a little bit more intuitive. So this will bring you a prompt, and you can type in a prompt, but I don't want to do that. And this will actually just describe the image. I probably should have put a tooltip to actually indicate that's what it did, but I thought a brain would be good enough. So as you notice this lag here, that lag is actually the biggest thing I'm concerned about with Android. Because once you actually get over here where you're actually generating text, it's pretty quick. It's pretty speedy. But that first lag where you're actually going through and processing all the visual tokens is, I mean, that's the thing that you notice. And you have to have a UI tool to mitigate that, to show that something's happening. And I mean, what I could have done is I could have had it sequentially, but then there's a concern about constantly going back to JNI and using JNI context to update the UI thread, and I didn't really want to do that. So that's basically how this app actually works. And I mean, the code's all open source, and anyone can take it down and mess with it. Now, the thing I don't like about this with Lambda CPP and using GPU or even CPU is that the more you use it, the more thermal problems you're going to have. And ideally, I'm actually investigating other ways to run VLMs that aren't Lambda.cpp because, like, this doesn't have any support for any of the accelerators that are on modern phones. Like, I mean, you'll never have tensor support, and you'll have to use LightRT for that. Now, I personally would rather use LightRT without MediaPipe because I find MediaPipe cumbersome and awful. But that's what Google offers, and like same, I would rather use Executorch without having to go through the Java API personally. But I haven't gotten a C++ API working yet with Executorch, so there's that. So there's a lot of work that has to be done. Unfortunately, it's all hobby work now since I have to go get a job. But yeah, this is sort of where I got to while exploring VLMs on device. And there are a lot of applications for if you're doing resource extraction or you're on a farm or things like that. And it would have been really great to explore this, and if I had more time to explore this. So that's kind of why I'm making this video, is just to sort of go through the code and sort of explain the thought process behind it and add a little video that goes with this blog post. So yeah, hope you enjoyed the video.